and thank you for joining us today for navigating the complexity of distributed microservices across AWS, Azure, and Google Cloud. My name is Raleigh Gould, and I'll be the moderator for today's event. Our featured speakers are Torsten Volk, Managing Research Director at EMA, and Jasper Paul, Principal Product Manager at ManageEngine Site24x7. With over 16 years of experience, Torsten helps end users and vendors leverage the opportunities presented by today's hybrid cloud and software-defined infrastructure environments in combination with advanced machine learning. He specializes in topics that lead the way from hybrid cloud and the SDDC toward a business-defined concept of enterprise IT. Jasper is passionate about all things AIOps, observability, cloud infrastructure, and FinOps. His tech expertise seamlessly merges with his financial acumen to optimize IT operations. Be it IT or life, Jasper finds joy in solving unique challenges with a smile. And before I hand things over to Torsten and Jasper, I wanted today's audience to know that they will be concluding today's presentation by taking your questions, so feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded, and you will receive a follow-up email from EMA with resources from today's event. So I hope you will check that email out. And now I'd like to go ahead and turn things over to our first featured speaker, Torsten Volk. Torsten?
Hi there. Thank you, Raleigh, for the intro. And I'll try to smile as well today when we talk about microservices and observability. Kind of to smile, I have created this cover sheet here, which is showing the complexity of microservices and specifically of establishing observability within microservices. There are lots and lots of options for people to choose from. And that almost always means that no two stacks are ever exactly the same. At least there's a different configuration, there's different versioning. There's always something different when you talk about individual stacks for microservices applications. Jasper, what's your take on this? Is this how do you like this picture there?
Yeah, so given the complexity of today's modern microservices, if you see in this graph itself, Kubernetes is now everyone is joining in this Kubernetes wave, and that brings in a lot of complexity itself, right? So and multiply that with the multi-cloud. And I'm sure you're going to talk a lot about the complexity that it's going to involve. Yeah. And one thing is, how do you observe that? How do you pick the needle from the haystack is something that's every engineer is going to be really interested in joining us.
Yeah. And just to set a little bit of a context, this is a automatically generated image based on 1,000 Stack Overflow posts. So the last 1,000 Stack Overflow posts from sometime in October, I forget exactly the day. And that's automatically clustered and then laid out by a statistical layout algorithm. So to provide a real overview of the nitty-gritty difficulties and challenges that Stack Overflow users, mostly developers, DevOps guys, are dealing with on a daily basis. And you already mentioned this was only the simplified view. This here is the full haystack, and we see the full extent of the complexity. And we have 1,040 problem categories all of a sudden. And that means that almost no two problems are ever the same, right?
Right.
It's a needle in the haystack search, Jasper.
Yeah. So interesting seeing this, because there are two worlds out there. One is the consumer world, where everything is now digital. My daughter was saying that why is this app slow? And she doesn't know. She's just born digital, right? And it's interesting to know from her or her friends that how they use the digital world today. They just go to the app, they download or they stream the YouTubes and the likes, and they play games, and all these are streaming, right? And they just take for granted the traffic, the amount of traffic and the amount of data that is getting transferred, and what is going to be. They never bother about the user experience, as they say, but underneath it is actually real user experience, right? So if the data is not there, or the app is not getting rendered as such, then they just leave the app, basically. They just leave the app and just go away. That's one world. And pivoting into the business world, it's a different whole different use case, where a lot of financials are involved, decision making is involved, and so on. And
the kids don't care about the stack, right? The kids just want their app to be cool and to work and to be fun, and that's all they care about. None of those boxes here means anything to them, or should mean anything to them.
Right.
Yeah. And so let's go away from the kind of the topology view and dive more into the individual stack. So we talk microservices, applications, and this is a standard microservices application here, an overview of that application. And we see all of the red little stickies are the different layers of the application. From all the way at the bottom, the infrastructure layer, to all the way up there, the service networking, where then different APIs can make up applications by themselves, and everything. Go ahead.
This is only a very few layers that we are talking about, is what I was saying.
Yeah, absolutely. And what we can see there is even every one of those layers, there are categories involved in each of those layers. And then in each of those categories, we have multiple product choices. And what I was trying to show with those little colorful stickies there, those mini stickies, those are kind of the connections to the observability platform, right? Those are notifications, alerts, logs, metrics, all of those telemetry data components that you see. So that shows a little bit the streams that you get when you extract telemetry data from everywhere. And it shows you also the amount of telemetry data, obviously, that you're getting out of microservices apps, because let's not forget, this is just a single microservice, not an entire application.
So yeah. And this is typically how organizations and enterprises have in their infrastructure. And interestingly, you also mentioned infrastructure as code, and how things have moved forward on how they deploy their infrastructure itself. That is through code. Tools like Terraform or Pulumi, or even the CLIs that all the cloud providers give. It's interesting that everything is now codified by and it's if you take the CI/CD pipeline itself, the infrastructure that is designed, that is architected, is set there, and then everything just follows, right? And in every step of the way, I think observability is one key, very, very key component that organizations are now realizing that they have missed previously, and they are now looking to how to onboard them, but then they wanted to have that as a codified platform. So they are looking for platforms like ours to smoothly dive into their ecosystem and their deployment strategies as well.
Yeah, and when you have all of this as code, you can just change things around. You can change versions. You can do all types of different testing, and it becomes all a really big puzzle. And a lot of people see observability just as logs, traces, and metrics, but observability really is knowing how those logs, traces, metrics, alerts, notifications, and so on, how they are interrelated, basically interpreting them. How does the application actually respond to a certain thing that comes at it from the outside, understanding this mechanism of response and being able to predict when the response will not be what you want, when your daughter gets really upset with that app and just deletes it from her phone. That's what we want to prevent, basically, with observability. And and just to show this from one microservice to, and I just picked a number. I don't want to say a random number. 25, I think, is a reasonable number for a lot of microservices apps that we see. It could be more, it's often less, but the idea is always the same. As you can see on the right-hand side, we separate out the individual capabilities that we need to compose the application. And what that gives us is the ability to work on each of them with a specialized team, a domain-specific team, and enhance each one of them. So if our product catalog is not good and people not responding well to that, we can release very quickly more product catalogs without also changing the user management or the pricing or the shopping cart parts. And all of those errors here, and this is also very much simplified, obviously, but they show the interrelations between the individual microservices, and they show basically also the impact that something has if something happens to a specific microservice. It's quite obvious for shopping cart. If that dies, you can't really sell anything with a shopping cart. But there's other microservices like the wish list or like things that don't seem to be in the critical path, where you don't really know what's the impact of that thing if it misbehaves, or if people just don't like using it, or if it doesn't work on a specific device, what's the impact of that? That's what we need to know. And that's kind of what, or not kind of, but that's what observability gets you. It gets you insights into all of those errors and basically an understanding of the app at a much deeper level. Jasper, is that your view as well?
Yeah. So you actually hit the nail on the head, because these are just microservices, and each microservices, if you take each microservices, if you take organizations are now acting as teams or business units. They'll have a payment gateway, or the people who interact with that vendor has a tech team, and the business logics. So the application team, that's a separate team. And if you see this, they are all kind of I would say small business units, and every individual team acts as a totally independent unit of the other, and the only interaction is through the APIs and the frameworks that they have built inside the organization. And some of them even may be traditional, right? So they would have a very traditional, even a mainframe system that is
That's a good point.
there, and they have to convert that. And those tech stack is totally different. And from the modern day, the Kubernetes and the likes, and the likes of things. So that is something that this graph, but they all have to interact with each other, and there is going to be there is bound to be some problems that are happening, and how observability stitches them is something worth investing. And if you take all these teams, there are different tool sets that each of them kind of use. And if you see the next slide, I think there will be a full stack observability system where you actually need to go through that, right? So so maybe you can talk about how this thing works, and then I'll continue with one of the use cases that I have, right?
Yeah, and this is basically showing the extent of the complexity, where we are we are hinting here when you have that picture of the microservice, the chart of the microservice about the notifications, logs, alerts, metrics, events, and traces. Now here you see that it's actually really more complex, as Jasper said before. There is more than just those 6 even. That there's network traps. There's all kinds of additional ways of gathering telemetry data, and so all of those little circles show different ways of gathering telemetry data, and the orange boxes basically show the main categories of the data that I'm collecting there. And you have to see each one of those microservices in the middle of that drawing generates these data points at most or all of its individual layers, from the app stack down to the cloud infrastructure. And those are the interdependencies that we need to worry about, and that we need to make transparent and actionable with observability, Jasper.
Right. Yeah. So we were recently working with a financial organization or a fintech company where they primarily wanted to consolidate all their observability stack, right? So they were using a lot of tools, and they were also migrating from a private cloud infrastructure to a modernized public cloud infrastructure. And then they have their legacy systems as well, so they wanted their network capabilities, simple SNMP, S-flow, NetFlow, all those telemetry data they wanted to push, but into the cloud. And they also had multi-cloud by design. Okay, when there's a failover, since it's financial, they wanted to have a lot of backup, and their backup systems were spread across different clouds, right? So that and they still wanted to observe everything, all the telemetry data, all the metrics, traces, and logs into one platform. And if you take even the microservices architecture, as I was saying, the business units chose different tech stack. So for example, some used the Java tech stack with Tomcat, and some used Node.js, and some of them the Windows stack with .NET and .NET Core. So, and there were a lot of small components, and the data store itself was different, right? So based on what microservice they were working on, their storage was different, their languages were different, and how they all interacted with each other. The CIO wanted a high-level top view, right? So are all the microservices working well? Are they available? How do you dig deep, and how do you give the teams relatively hands-on experience, but some form of I would say uniqueness to their teams, isolation, right?
Yeah.
And then yet they're all connected, and how that connection happens. So all they chose us because we are a full stack observability platform, and all these telemetry data, the metrics, traces, and logs, we were able to ingest at real time, and we were able to give them a lot of insights with dashboards and reporting and alerting with our AI engine. So that played a very vital role in them choosing us, and also the geographical locations that we have in the product. We have over 6 data centers worldwide, and their business units across the world had potentially they could onboard them very easily. So that's one use case that we very recently were talking with, and they have now onboarded and then using us. So
and the key, Jasper, sorry to interrupt, but the key there is that you don't have any gaps, right? we always talk about AIOps and about large language models and all of the latest and greatest tech. If you don't have the data and the data in a form that is complete and that also reflects the relationships, then you can't really do all that much.
Exactly. And that was one of their primary goals, to unify the data. And there are tools available in the market where there is event driven and more of English driven correlation. But when we have the observability platform and all these data are real time, the scale of things that how AI itself is done with all these correlation is totally on a different level, right? So with the amount of data that is real time, so I mean, real time meaning it is actually real time. It's per minute, and it's, you get so much quality of data and the telemetry that's there. So you're talking about this network telemetry as well. Network is a different world, right? And we have these network engineers bothering only about the network, and the application team blaming the network engineers and vice versa. This fight, this blame game goes on.
Yeah.
But
or if I'm a developer, I pick any of those boxes, right? And I just put as an example just one single metric in that box. If I can pick any of those boxes where I say, ooh, there is a 15 milliseconds lag in response, for example, of a cache. Is that bad or is that good, right? I mean, the network guys can say, ooh, that's easily within the limits, that is a great actually value. And the app guy says, no, that's exactly what breaks my app, or that's what causes latency to me.
Exactly. And that is when the anomaly is kicking, right? So the unit of time it's quite important there. So when you take the network world and these guys say it's properly, it's definitely fine. And when you see the end user, I took the example of how my daughter uses the app, and a delay of half a second and your app experience is gone. And she just switches over to another app, or just goes out for a different thing. So that's the amount of time concentration that the new generation has, and that has an impact on all these layers.
And the interesting thing is also, when I was talking about like 20 milliseconds or any number of milliseconds, that may not matter by itself, but if you pick each color, if you pick a metric from each of the different colors and you get a different value, there can be constellations where the 30 milliseconds or 20 or whatever milliseconds matter. And most of the other correlations, 95%, they don't matter, right? And it's totally fine, or it's always been fine for other applications. And that is really the interesting things. Those are the needles in the haystack, when it's typically fine and it's a totally normal number, but under a specific correlation of circumstances, it is degrading the user experience in your daughter.
That's continuous monitoring or continuous observability of metrics is vital, because you'll see a very straight line, and the straight line will be like less than 15 milliseconds, and there's going to be one spike or two spikes or a continuous number of spikes, which will say just about 20 or 30 milliseconds, but it's still a spike, right? And that's an anomaly. And how that is learned, and over time how that is adopted into the system, and what kinds of alerting and notifications that your team is getting is very vital to your system's overall experience.
Yeah. And just to demonstrate that, this is a simplified chart on the right, that if any of those events happen, right, if we get a latency, or if we get any types of issues, error messages in the application or in the infrastructure stack, we ask ourselves 4 key questions. And in reality, there will be more sub-questions to that, but 4 key ones. And that is, who will be impacted? To what extent are they going to be impacted? What is the cost of the impact of the downtime or of the performance degradation? And what's the impact on the business overall? That's the last question, right? Is there a revenue loss? Are we losing reputation? Are we losing important customers? And each of those boxes on the previous chart here, each of those little nitty-gritty things with a timestamp that goes down to the second level has an importance in that bigger scheme of things. So that's what observability gives us. We have no idea what the individual metric means, or even what the overall network metrics at this point in time mean. Maybe the lights are all red, but maybe I don't care because it's affecting a development environment somewhere. Maybe the development environment is hardly used, or it's not used on that day. So this whole business context is absolutely critical.
Right. Yeah.
And I'm just going to move to the next one. And this shows, again, that feedback loop where we connect the dots between the telemetry data that we are getting out of our application, like user experience indicators, security metrics, all kinds of custom metrics, all kinds of things that the application spits out in terms of telemetry. And this telemetry directly influences the technology, the higher level technology KPIs, like the application quality, the cost, the user experience overall, the delivery speed. So at that level, we can see, oh, okay, here's the impact of all of those little things on a bigger thing like resiliency, right? Because those certain kind of metrics cause us a certain number of hours a month in outage, apparently. That seems to be what it is. Obviously, I want to confirm that with my observability platform, so that I have a actually justified correlation between the different events. And at the top is the business KPIs, right? That's what I really care about: the profit, the revenue, the user retention, the predictability of my business. And yeah, that's overall why we are doing all this. And that's the new thing, right? And I said to Jasper that we are always drawing that bridge between telemetry data, between technology and business. And that we've drawn that for, I feel like 20 years, maybe longer. And the bridge has never really existed. We've just drawn it and we thought, oh yeah, that's what we have to do. But in reality, most of us still had individual silos where we were gathering our log data for our IIS or our Linux distribution. And we would have the metrics totally separate for the different things. And we would have the traces obviously entirely separate that only the developers would use, and nothing would be correlated. And the interesting part and the real value about observability and why it's different from monitoring and different from everything else that we know is that it ingests data from all of those different levels and analyzes that data, and then recommends an action or warns you of something that may happen based on the business impact, right? It doesn't warn you, oh, this volume may fail of that disk, right? That's what you use monitoring for. Disk volume may fail, but it says, ooh, there will be a revenue impact. And then you say, why? And then it says, oh, because those disks show early signs of failure, and you don't want to neglect that. And then you think, oh, but there's red lights on something else that seems to be more imminent. But the observability platform knows that this more imminent stuff can maybe wait because it doesn't have a revenue impact. Jasper, I didn't want to interrupt you.
Yeah. So yeah, it's very interesting that you say this, because now we have started getting customers where the technology and the business KPIs tend to be merging, right? So they want what is the revenue impact on the technology that we have used, and because that's a lot of investment that is being made in the technology itself, and customers really want the value of how the technology is impacting a business. And that's when real-time observability kicks in, right? So we recently had a multi-brand automotive distributor who wanted to onboard to our cloud system. They are also migrating from native to cloud system, and they wanted the lead funnel to be captured in real time as an observability project, right? So just when the lead is coming in to a website, they want the total number of web sessions, and they wanted to drill down to each and every step of the way till the lead is put into a CRM.
That means each one of those boxes on the chart, right, that we just showed with all of the stickies that showed all the networking layers, each one of those boxes is basically directly tied to a lead.
Right, exactly. And the interesting point is not all are in one place. Some of them are in logs, some of them are in metrics, some of them are in real user an application, and some of them are just in the browser itself, right? So how they want that telemetry and what was the failure in each step of the way is something that they actually wanted. And if you go to the next slide, they actually they wanted this journey. This is their full journey from a website, and how we incorporated feature sets that we have in the system and connected the dots and gave them a dashboard. We are still building them dashboards and giving them insights and how they wanted to translate that technical KPIs into a business outcome, right? So that is when they wanted us to step in, and we helped them to fetch data from logs. So they had this unique identifier that runs across the system, and we had to filter that out from the logs and put them into as a separate unique column. And from that column, we had to we queried the log structure. We have a query interface for all the logs so that it's easily queryable, and the metrics are given to them. So if you see each box, they had an observability injected, and with either a trace or a log or a metric. So if you say the Kafka stream, the codes and the leads, and finally it goes to the CRM. We work with the CRM team from their side to inject back the trace ID, or they call a unique ID, so that it brings back, and that success rate is also ingested into the system. So this was one really good use case for real-time observability that we have worked with, and it's basically sums up how technology KPIs and business KPIs give the overall picture, and why observability and real-time observability plays a very important role here, right?
Yeah, many years ago, 10 years ago, so I called this the business-defined data center, and everybody was shaking their head and talked with all kinds of experts and practitioners, and they just it was just so far away. For me as an analyst, it's easy to draw something up that connects the business outcome to each and every log that you collect in every second. That's, to me, that makes sense. But if you're in the trenches and if you're working on that for a large company, you do log management and you have to deal with terabytes and terabytes of logs every day, then you get buried under all this complexity. And it makes me really happy, and I hadn't seen this slide until a couple of days ago, but it makes me really happy that you guys pulled off something like that, because that is that original, I almost want to say, dream of having every single technological aspect connected to your leads in the pipeline. So you see the impact of a certain thing. You see maybe the impact of a smaller class of AWS servers that cause a little bit more latency, and that may destroy some of your leads, or it may just not matter. You can do all of that experimentation, and you can see all of that data in real time. That's absolutely fascinating.
Because both the traces and metrics and logs are in real time. They were quite happy with the final dashboard that they had, and these guys are still implementing and then giving us inputs, or some of the gaps where the business metrics are not available, and they want to help us. And so we are this ongoing loop of how things go, how we improve, and how we work with customers. Now all these things, as a product manager, it really excites me, because at the end of the day, I'm from the product which I've worked with for so many years, and it's bringing fruit to a customer, and it obviously makes us happy, right? So, and this thing of the technicality of how do you give solutions with the team, the whole team has worked with them, and these are some of the joys that comes out of working with customers, like new solution or new problem to solve.
Yeah. And it's really every dollar that you spend, and that's a nice segue into the AI slide and the brief AI discussion that we want to have. Every dollar that you spend on technology, on cloud resources or human resources, you want the biggest possible business value, right? You don't want the fastest possible application or the coolest application or the least downtime. None of that matters if you don't convert your leads and if you can't collect your leads. So that is the key, and that is where AI, as we call it, I mean, again, I've been struggling with that term for years now, but let's just call it all AI. That's where it gives us quite a lot of power that we didn't have as human beings, right? Those are things that you can't calculate easily in a spreadsheet. And applying formulas manually is not something that you can, as an organization of a certain size, really do. But if you use any of those types of AI, and I've just plotted the 8 categories that I thought are the most relevant off the top of my head. So if you look at each one of them, they all give you a specific ability. As long as you have that data that Jasper was just showing, they let you take that data, or they take that data, and basically the anomaly detection tells you, oh, that is something that usually that's an event that usually doesn't happen. That's a constellation that seems significant, at least statistically. And if you then combine that with reinforcement learning in the middle on the right here, if you combine it with reinforcement learning, then you can enhance that paradigm. You can say, oh, that anomaly in the past was usually significant in a certain constellation of things. We always use Black Friday, or we use some other special events, or we say, oh yeah, on the weekends it doesn't matter. And it learns that through reinforcement learning continuously. And so you can really combine a lot of those categories here that you see together. Then next you use clustering, and you cluster together the types of errors that you're getting. What's part of that anomaly? What cluster of issues belongs to that? And that way, cleverly combining all of this. And again, we call it AI. It is a bunch of algorithms and models, obviously, that somebody who knows how to build software interconnects and then turns into something that aligns your technology and your business, and that gives you actually actionable advice, actionable insights and recommendations. Jasper.
Yeah, right. So it's a very interesting that you see these boxes, and specifically on the reinforcement learning part, because these are seasonal values, right? So you were saying about the Black Friday or a weekend. It can also go reverse, right? So on a weekend, there's going to be huge traffic, and or on a business day, there's going to be less, because of the amount of type of application that you're going to get. this learning and this detection and this pattern, obviously there are algorithms like multivariate and univariate algorithms, matrix sketching, that are applied, and then you get an outcome, right? And then you build that into the system, where we have built something called as the dynamic thresholding, where the mundane tasks of conferring some thresholds for alerting and notification system is taken care of by the AI engine itself. And that is going to, reduce a ton of alerts, a ton of noise, and it's also going to reduce your noise fatigue, alert fatigue, and the reverse as well. So if you want to predict, if you want to forecast things, and let's say a disk is going to get full in, let's say, 7 days or 10 days or 14 days or a month, and if the AI engine is able to alert you prior to actually getting that, with the threshold, and obviously into the alerting system, where you go to let's say you integrated with an ITSM tool, and that action or the reaction what the other teams, the operational teams, take is vital for the business itself, and that ties in back again to the business KPIs. So
and you mentioned this dynamic thresholding. That has been a problem also. I don't even know. There was a whole bunch of startups at a certain point around that, and I think most of them are gone or acquired for not much money, because dynamic thresholding never really gave people the advantages they thought they could get, because the dynamic thresholds were just limited to a specific domain, and unless you have enough context, ideally even business level context, then it's just an academic exercise to calculate a dynamic threshold, right? I can easily calculate a dynamic threshold that makes sure that in a lab environment, my application will never go over X amount of seconds, But I also need to know that X amounts of seconds even matter. Maybe, it's for old people like me and we can wait. So there may not be revenue impact. So that dynamic threshold should be different than for Jasper's daughter to just stress that image. And that goes very much into the FinOps perspective, as we always like to talk about, where we can see and manage that trade-off between spending money on tools and resources and people and automating things, all of those things that we know we need to do, but we can't all do at the same time, and we can't all do perfectly well, because otherwise nobody could pay for a product anymore. There's always a compromise, and that's basically what FinOps is. It helps you plan out that compromise under as much contextual information as you can possibly get. So you monitor your cost, you observe cost spikes in certain situations, you see those cost spikes coincide with something else, and you do something about it, and then you observe the result of what you've done. Like you scale down, you move to another database or to a lower instance level, and you see, oh, that doesn't actually affect my application or my user experience or my revenue at the end at all, so I can keep doing that, and it learns. You use AI to learn that, and then you apply that same principle to other areas in the organization, because what you just found out may be true for a lot of other teams as well. And to stay with Jasper and his company, you can even cross-pollinate across organizations, where you learn something, you learn that a specific metric matters in a specific situation, and then you can automatically adjust your auto-thresholding algorithm based on that knowledge without giving away any data, really. You just cross-connect that in the background. Jasper, am I overdoing my vision there a little bit?
Yeah. So this FinOps practice is actually very unique, because FinOps itself, the word FinOps itself, is relatively new in this operation space, and so we invested in this FinOps space some years ago, and to get the benefit out of the cost, the primary reason was because the tech world was going into cloud, right? And cloud happened to be these big public clouds that are existing. And the story went from the large investments that were made to very, very short or very concise investments that were possible through cloud. Right. And then that's when this unique segment or this unique persona of what a FinOps practitioner is going to do and how it ties with the overall observability and operation side of things came into fore. And what we were able to do is we were able to segregate these segments. If you go to the next slide, I think the uniqueness of how observability and FinOps tie and these challenges of how cloud builds were done and how they are parsed and how they are identifying cost leakages, multi-currency support when there are different regions across the world, and how business units are tied across these regions, and now how you pay the bill, basically, right? This brought in unique cases where we could auto-remediate certain portions of your IT, especially when someone forgets to turn off their instance. And I think there are a lot of reports now that saying that the cloud cost wastage itself amounts to more than 50-60% of how the cloud is being used. Right.
Yeah.
And to optimize that and to optimize that solution, and to automate this through cloud monitoring itself. Right. So it comes back, it circulates back to the observability that comes into fore. Right. So we had this one use case where these guys they found out there was a leak, and they wanted to use the system to remediate the problem. And they actually found out that because they had we gave them a guidance report, and that there were a lot of underutilized resources. And from that report, they took some actions, and they were able to auto-remediate. And then right-sizing recommendations and the integration of the overall ecosystem of all the clouds, the multi-clouds, and observability ties in very well with the overall business KPIs and how analytics is done.
Yeah.
And this gives not only the finance control, but also the observability that they need to take action on, right?
Yeah. They need to know how the system works under the covers. And interestingly enough, you mentioned those 50% waste. Literally, I mean, I remember a specific research project that we did, I think it was 8 years ago, where we had the same 50% waste, and that has not changed. And that waste is everywhere, right? It is, we can see it when you have a VM. Maybe you should use a container instead, where because it needs only to run 5 minutes out of 2 hours every day, right? And you use a container and you run it there, and then you kill it again, versus leaving a VM on all of that time. And that is a tremendous cost difference. And then, interestingly enough, we talk about observability, and I have no idea about how Jasper's tool handles this, but there is observability platforms that then still charge you for a full hour of observability, for example, even if you only use it for 5 minutes, that instance, because it counts toward how many instances you're observing per hour, right? And then you have a significant additional price tag attached to that when you thought, I'm saving a lot. You're not saving anything, you're just paying the observability vendor instead of the cloud vendor. So there's a lot of interesting considerations that you need to have here. Jasper, did I interrupt you? Or
no, yeah, you just said what I wanted to say. Yeah,
All right. Just before we run out of time, the key takeaways are, and that's something I mentioned this many times because it's so close to my heart, and I've worked with lots of companies as in the software area and also in the IT MSP and services area. The gaps are what's killing everything. You know, the gaps where you say, oh yeah, I couldn't monitor my Windows environment because we are mostly a Linux shop and we just have gaps in Windows monitoring. Or our Windows and our Linux teams don't talk enough, and they don't have their monitoring well enough integrated. So all of those gaps are basically blind spots, and those blind spots generate risk. Or for another reason, you know, if you just don't want to monitor because it costs too much money. We hear this all the time as well, where saying, yeah, we can't log the way we want to, because if we do that, then, you know, we pay X amount for logging, and then it's not actually worth it anymore because, you know, we'd rather just get the do what we need to do and be done with it. And that's another big problem, where we are then basically having a blind eye toward that risk. You know, we know there is some risk or a lot of risk, but we don't know how much it is because we don't have the data streams, because they are too expensive. And what we want out of an observability platform is that we get actionable insights. And by actionable, I mean things that can be alerts, things that can be proactive recommendations, where basically says, you know, you are spending too much money on storage, and I tell you why, you know, and then you get a couple of bullets why you are spending too much money on storage and why spending less money wouldn't be a big risk, and a recommendation of, oh, move to that tier of storage, or, you know, do a certain other thing, or stop over provisioning so much storage because the over provisioning doesn't give you any performance differences. Those are really the things. And yeah, at the end, we have to see it's all a collaborative effort, where we are balancing between cost, between resiliency, compliance, performance, security, all of those things, and finding the best way forward and the best path to spend our IT dollars for the biggest possible business impact. I think somebody raised their hands there. But go ahead, Jasper, if you want to finish this off. We get to Kartik in a second.
Yeah, so yeah, to finalize, to summarize, so what you're saying, observability with actionable insights is vital, and you know, to optimize this in a collaborative way, and how tool sets help to get through that, or to get that, is something that we have been working on for over 15 years. So ManageEngine itself is an IT management solution, and observability, cloud observability especially, came into foray. And Site24x7, the ManageEngine Site24x7 is a full stack observability platform. I think Torsten, you can go to the next slide probably. Yeah, so Site24x7 is actually a full stack observability platform, and there is a unique product called as ManageEngine Cloud Spend as well, which is a FinOps product. And then these two tie together with both FinOps and observability to give a wholesome solution, which we were all talking about. So do visit site247.com and experience the full stack observability that you guys want to. Okay, and I think that brings us to the end of the session, and then I'll hand it over to Relay for Q&A.
Great, thank you. Let's dive right in. The first question is, we are using AWS S3. We spend more money on storage. Are there other alternatives? What are you both seeing?
Okay. Torsten, do you want to take that?
Well, I mean, it's an interesting question, right? I mean, I think that's the FinOps challenge. There is all kinds of different tiers of storage, and different options of doing storage and of managing storage, you know, the management of storage and what are the requirements in terms of where compliance, where does the storage have to be located? How highly available does it have to be, right? There's a lot of considerations, and this is something, you know, it's almost like a trick question. I don't think it was, but could be a trick question, right? It is, you need to see it within the context of the organization.
From S3 as well. And there are archiving options that you can use in AWS. Maybe you can, you should probably dig deeper to find out what those solutions are to actually using S3. So S3 itself is relatively economical, I would say, and how do you spend, or where do you spend, or how long do you store really matters. So if you want to archive some data in S3, there are other options that AWS themselves give to store, right? And it comes at a cheaper cost.
And there's even S3, you know, everything is S3 compatible. The S3 API, everybody supports that. So you can even do on-prem S3 storage. There's a bunch of open source projects and commercial projects that allow you to do that.
Great. Thank you both for your insights. Jasper, jumping over to you, how does Site24x7 help in troubleshooting modern applications?
Yeah, so like I was saying, this full stack observability platform, when there are different tool sets, data is siloed, right? So if you take a metric system, metrics data is siloed, and if you take logs or traces, all of them are very siloed in nature. And when you bring that all together into a full stack platform, and you see this influx of data that is coming in, that is when it gives real value, and that is when you get to find out these problems in real time. And that's when Site24x7 helps in observing it in real time. And the applications and the infrastructure that we are able to monitor, which we are able to monitor over 600 plus technologies, and all those metrics, all those telemetry, when it's ingested into the same platform and the same data store, you get very insights that are giving decision makers, or the tech team, the ability to decide faster and to solve their outages or their performance problem much faster than coordinating with a lot of siloed tools and then coming to a solution. So that's when Site24x7 really helps as a full stack observability platform.
Yeah, it's monitoring versus, it's observability versus monitoring, right? You have all those arrows, those dotted arrows and those red arrows in there that you understand, and you need to understand to see what the situation currently is, and if that red light actually matters or not.
Yeah.
Great. Thank you both. That does bring us to the top of the hour, so that will wrap up today's event. I wanted to thank you all for joining us. As I mentioned, you will be receiving a follow-up email from EMA with resources from today's event, so please check that email out. And I hope we'll see you at a future EMA Research webinar. Thank you again for joining us, and enjoy the rest of your day.
Thanks, Raleigh.
Thank you. Yeah.